Okay, hello. Today we're going to be talking about a campus area network, and the goal of this was to set up a campus area network for 5 buildings: art, law, health, education, engineering. I did this using router on a stick to separate VLANs. I have one central core switch. As you can see, the naming conventions are pretty much self-explanatory. There is 8 different networks or LANs in here in total. There is 6 virtualized networks and 2 physical, which is 192.168.1.0. That's for our DHCP server. And then 10.10.16.0. That's going to be for our ISP. It's going to be our WAN link. Um, and then we have our VLANs over here. Our VLAN 99 is going to be management. This is going to be any networking device that we're going to use. So, like our wireless LAN controller, our radius server, our switch is going to have a management interface. And then every single one of the APs also contains the same convention for it. All of this is done through DHCP for the APs. And then we also have our HTTP server, which is on VLAN 50. That is just to separate it from everything else. You don't really want HTTP traffic, and if we're going to do a granular approach, we might as well VLAN it because we get more servers. Then you have our BYOD. This is our least trusted VLAN or sub interface on our router. Uh, that is because people bring their own devices. You don't know what can be on them. And then you also have your guest network, which is pretty much right up there with BYOD. This is going to be similar, 192.168.30.0. Then you have the students and the faculty networks. These are VLAN 20 and 10. These are going to be our most trusted. These are going to use 802.1x for authentication. And then we have our underlying infrastructure, which is going to be our router. A router is going to be doing the router on a stick. It's going to be doing the sub interfaces for each VLAN, and it's also the gateway for each of the VLAN and the devices. And then connected to that router, we have the DHCP server. This is on a separate network entirely. This is just more provisioning. It's technically on VLAN 1, but I'm not counting it because it's just not really matter. And then here we have our DHCP pools, and these DHCP pools are going to be for every VLAN, including our management VLAN. And the naming, ignore the naming for this, it's kind of off, but that DHCP is going to be provided to the APs, the end devices, and then once we get into it more, we'll see that we have the HTTP server, the radius server, but the APs are broadcasting every single network, uh, including from those VLANs as we saw over here, is that each of these networks is being broadcast. Not all of them have the same access. And what that means is because we have this radius server here, if we go into it, we look at AAA, we can see that the radius server is connected to the wireless LAN controller. Here's the passcode, and then here's some users. You can't inherently separate users by VLAN on this radius server unless I did something like attached it to the wireless LAN controller via 2 separate radius servers, which I'm not going to do. It's too much. It's too much of a process to do that, and the wireless LAN controller is honestly really slow. But as you can see here, here is all of our addresses for our wireless LAN controller for each VLAN. Ignore virtual, that's just a basic one that should have been deleted by me. Ignore it, but we have those here, and then if we go to our security, we can also see our AAA server, our radius server. It's on port 1645, which we saw before. And then we can go to our WLANs. But another cool thing to look at is my decision on VLANing them this way. It originally was supposed to be that there was going to be 5 buildings, 5 separate VLANs for each building. But I was like, in a college campus, you're going to be walking to building to building. It's not really going to make sense to disassociate and reassociate at the next building, type in a new password and everything. And the best part about that is college students get their own Microsoft or whatever, however they do it. So as you can see here, we have our 802.1x authentication for our faculty and student. They're going to have Entra IDs or Microsoft E1 accounts that they can, even an Exchange account, they can log in with some sort of credential, get in there, attached to Active Directory or Azure, and that's going to be pretty useful for onboarding users onto the network manually or automatically. And then you have the guest and the BYOD. BYOD and guest are least trusted, so they're going to be passkey because they're not going to have Microsoft or credentials that they can access, so those are separated. But that's pretty much it for that. And then if we go into here, wait for that, but also if you check it out, each one of these APs is broadcasting all 4 of those networks, and then they all have a management IP address. And if we go to, say, a faculty computer, our configuration for wireless, you can see it's WPA2, it's going to be AES encryption, and the user ID and password is TomTom. That's one of our users in our Radius server. And the cool part about it is also you go over to here, say, okay, student or faculty member 1 is going from art and they're leaving art and going to law. So once they go to law, right here, so they left, going to law, oh, reassociates with AP. And the good part about that is that the students aren't going to have to be typing in their credentials every 10 minutes. And then preferably we'd have some configuration where it's like DHCP each of these pools we have for our VLANs, so say VLAN 10 and VLAN 20 for our faculty and students, those would have lease times of like 8 to 12 hours. This would give them ample time to be connected to there and then be disassociated when they go home, or if they've left by then, that IP address doesn't need to be taken up that whole time. And then for the Guest and BYOD, those would be lease times of like maybe 2 to 4 hours, making authentication important. And then also from that physical perspective, we can see that there's some overlap here. These are each considered to be one building. There's one AP in each building, but sometimes, I mean, you'll be split in between and they'll connect. As I said, the encryption is AES, and then it's 802.1x authentication. And if we go to our router over here, we also have some access lists, and what this does is prevents some of the communications into our internal resources for the college, so they cannot access that. And this basically blocks the guest and the BYOD from accessing our HTTP server. So if we go to faculty, desktop, web browser, of course it freezes. Enter that in, go. Alright, you can see access is granted, but then you go to the BYOD, desktop, applications. It's on me. There it goes. Okay, same page. It should time out. But what this does is it makes it, that access list makes it so that the guest and the BYOD cannot access our internal resources. However, our students and faculty can. Okay, thanks for watching.